put this slide a while ago because I remember that there was a lot of debate and a lot of topic. So this is like a panel that got together. It's called the Intergovernmental Panel on Climate Change. And there was a consensus, okay, about what's happening. So 90 to 99% likely that the lower atmosphere is warming. So they all agree, yes. Average temperatures increase about 0.74. Remember, I say it's like a degree between, you should know, a certain amount of years. Annual greenhouse gas emissions are up 70% from 1970 to 2005. Arctic temperatures rising almost twice as fast as the rest of the Earth. Melting of glaciers and floating sea ice. Prolonged droughts. And in the last 100 years, sea levels rose 10 to 20 centimeters. So a lot of things going on. Here's a picture of, and this is old because this is 2004, but this is what it looked like at a certain time of the year. This is the same time of the year. So if I make the picture bigger, and you guys could probably see this better than I do, but I can't see what it says. Whatever. It's from Cengage Learning, so yeah. You obviously can see the difference. And then you see the mass of ice, yeah, the difference there in 1979, September 2007. So what I'm trying to show you, it's not like they're taking these pictures in July and then in September. It's the same month where you're supposed to see the same climate is supposed to be the same from one year to the next. And it's obviously drastically different. I have a video, I hope I find it to show you. Sea level changes, and again, sea levels has risen worldwide approximately 4.88 inches during the last century. So in the last 100 years, that's the increase. Sea level has been rising, you know, that seems like minimal, but per year, yeah, something very scary. And then I put a picture of Florida because, yeah, shall we be worried? We're surrounded by water, yeah. And the red is like danger zone. No, the border of everybody that lives in the water, yeah. All right, tipping point. Have you heard this term? Yes. So that's a point where there's no matter what we do, we can't go back. So it's like the point of no return, I guess. And we don't want to get there, but supposedly there is some talk that like the melting of the ice caps is at the tipping point. Those are things that have been saying, and I really can't quote anything like that because I have to look up exact facts. I should have left that as an assignment for you, but yeah, we'll talk more about these when I get like more current data. Okay, pause to the bottom. So climate change problems, or you know, some specific things you need to know, and yes, you need to know this. Species, obviously birds migration patterns are changing because they're like indicator species, right? And they go, oh, look what's happening, let's move. What do you think is happening with insects, fungi, microbes?
They're moving like more south.
Increasing. Everything is more south. That was a good response, but if the earth is warming, then they're more prone to be, so there's a fear that their population is growing and stronger in that sense. Most susceptible ecosystems, coral reefs, polar seas, coastal wetlands, alpine and Arctic tundra, and forest. Yeah, susceptible means they're prone to damage or danger. Extreme weather in some areas, heat waves and droughts, prolonged rains and flooding. Totally experiencing that. You got to think of crops as a big problem. Farm shifting, less productivity because the soil's less fertile, because if you have higher temperatures or droughts or even floods, I mean, it's going to affect the whole crop. And genetically engineered crops become more tolerant to drought. We're gonna talk about that. So you kind of leave that one off because that's a whole chapter for us. And economics, I mean, financial, you have to think of financial loss or investment even to figure out how to solve these problems. So that's a big factor. How can we help this situation is important. And obviously awareness is always key, but what else can we do? What's the biggest, you think, contributor to global warming? Transportation, because of carbon dioxide, which comes from burning fossil fuels, okay? Burning fossil fuels produces carbon dioxide, which is a greenhouse gas. Nitrous oxide, is that a greenhouse gas? Yes? Yes, okay? Sulfur oxides is not a greenhouse gas, but it leads acid rain, so you're gonna get confused with those. But transportation emits all our primary air pollutants, but it's linked to carbon dioxide and nitrous oxide, which are greenhouse gases, and water, because there's water loss too. So what do you think we need to do to stop or help this situation? Shift to what? Shift to renewable energy. What else can we do with the energy that we're using now? Like, what does FPL do for you if you change your air conditioning unit? Anybody know? They give you money. So if you increase the efficiency of your devices that you currently have, you're saving energy or using less, which is a great way to reduce the problem. Reduce greenhouse gases by doing that, okay? Because that's basically, this should be like in between this and this, really. Slow what? What's always going to be the answer? Population, yeah. It's terrible to say, but if overpopulation is the leading cause of all environmental problems, then if we slow population, supposedly we're aiding in reduction of cars and, I mean, I hate to say it, but. And stop cutting down forests. Why? Let's say that's your essay question on the test. Because they take in CO2 and reduce its levels in the atmosphere. Thank you. Taking away a greenhouse gas. Good. That this term right here, Kyoto Protocol, is linked to global warming and greenhouse effect and climate change. And I'll click on this link, but I'm going to get out of the. It's an international agreement linked to the United Nations. What are the United Nations? The leaders of the nations coming together and agreeing on specific terms for the world, yeah? So on climate change, which commits its parties by setting internationally binding emission reduction targets. So you want to know that this came into play because obviously the world is concerned with this topic. So they're all agreeing to specific standards of emissions as a world to try to help reduce greenhouse gas emissions, okay? And you don't really have to know all the specific details, but you do have to know that that term is like a big step of the world to reduce emissions of greenhouse gases. It is only 3 minutes. Okay. So ozone, we know does what? From UV rays. So think about that Venn diagram we were doing, and you already found a similarity, yeah? Where is it found? Stratosphere, okay? It's also found in the troposphere, but if it's shielding us from UV rays, it's in the stratosphere and it's good ozone. What is the #1 ozone depleting gas? Anybody know? It's chlorine-based compound, which is called chlorofluorocarbons. Also, halons and hydroborofluorocarbons. Yeah, I know.
We didn't know that.
Hydroborofluorocarbons. You do need to know that.
Like that word?
Yes. And chlorofluorocarbons is really the biggest problem. Yeah, really. So Jonathan said chlorine-based. So you know, CFCs stay in the atmosphere for like up to 65 to 385 years. I always said, what did they do? Tag a CFC molecule and just watch it? Basically, what they're trying to say is it doesn't break apart, okay? The only thing that breaks it apart is UV rays. And then you'll see how bad it is after that. What produces CFCs? Anybody know? Good. Aerosol cans. Have you ever looked at an aerosol can that has a little triangle and it says ozone friendly? All CFCs were removed from aerosol cans. So they have been banned from aerosol cans. CFCs were banned in the United States. Look, if I was to ask you when, based on this graph, what would you say?
91.
Yeah, basically around, I mean, they put 89 here because that's when awareness kicked in. And from here to here, this is the drastic stop. When I tell you something really bad and they make a really sharp decision, this is one of them. Coolants, that's where. Have you ever needed Freon on your air conditioning unit? And the AC guy is like, oh, I can't do it. Because it's very difficult to get it because it has CFCs. Foams and solvents also. So the Montreal Protocol is the name you need to know that's linked to ozone depletion. So the ozone depletion reaction, we know starts with what? Number one, depleting ozone, chlorofluorocarbons. So ultraviolet light strikes this molecule or this compound. UV hits this compound, and look, based on the diagram, what happens? Causes a chlorine to break off. Look at the picture, and if the picture helps you, then it's better than the words. Learn it by photo. You have a CFC molecule, UV rays come down and hit it. Where is this molecule anyway? Where? Stratosphere. Very few molecules make it to the stratosphere, but this one does because nothing broke it apart in the troposphere. So no compounds were attracted to CFC, nothing broke it apart. It just kept going, 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 and made it all the way to the stratosphere. And then you got this free chlorine. What's this right here? Ozone. Chlorine reacts with ozone, and what happens? Look at the diagram. No more ozone. And what's left over? No more ozone. What's this? Oxygen gas, O2. And what's this? Chlorine monoxide. So you have no more ozone. Write in your notes right there. No more ozone. The hole just formed. That molecule that was protecting us from UV rays is now broken apart. So it's gone. This diagram. Tell me if you see the danger. The oxygen binds with what? No. The oxygen binds with or collides with chlorine monoxide and forms what? Look at this diagram. Don't guess. Oxygen gas and what? And a free-floating chlorine. And there you go. So this guy right here is going to go back here and do that all over again. And according to scientists, a single chlorine can destroy 100,000 ozone molecules. How bad is that? These clouds, stratospheric clouds, actually accelerate this reaction. So consider it like a catalyst, yeah? And I put this little thing here because this came out once, that CFCs are toxic, corrosive. They actually have odor, so they're like sulfur in that sense because you know the rest are like odorless, colorless, right? And flammable. They're terrible. Toxic, corrosive, and flammable. Those are like the three hazardous terms.